Okay, now for 1.2, I'm going to use the same stuff I used for 1.1. This is the second problem on the first batch. Okay, we're using the quadratic formula to solve a quadratic equation. Now, the quadratic equation is of the form ax squared plus bx plus c equals 0. Solutions are x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That c is not written very well there, and that might be a little hard to read, but I've written it up here. And I've noted that b squared minus 4ac, the thing under your square root, is what we call the discriminant. And that discriminant is important, but the whole task of using the quadratic formula to solve a quadratic equation is, first of all, you got to know the equation. And ideally, you know how to derive the equation by completing the square, but probably not. Okay? And if you do, that's a real feather in your cap. That's great. First, you got to know completing the square. That's a challenge. Okay. The discriminant tells you how many solutions there are. So to solve this equation, okay, this is our first equation, so let's solve this one. I think we've already done it, but we identify A, B, and C. A is what goes in front of x squared, B is what goes in front of x, C is the number you have left over on the left-hand side. So A, B, and C have the values 1, 3, and 5. When we evaluate the discriminant, we find that it's negative. And once we've mastered what the discriminant tells us, which is the first problem, is we see that this means there are going to be two conjugate complex solutions, because the negative 11 is going to go in here. The square root of negative 11 is going to be 11i, the imaginary number, square root of 11i, and we're going to have plus or minus that. It's going to give us one complex number for the plus, another complex number for the minus. So we proceed to plug in b here, and then plus or minus the discriminant divided by 2 times a. And we simplify that. We get negative 3 halves, and we get the square root of negative 11, which is square root of 11i, also divided by 2. Because remember, this division distributes over this plus or minus, okay? A division distributes over addition or subtraction, because a division is nothing but multiplication by a reciprocal, and multiplication distributes over addition and subtraction. Okay, so we get two complex valued solutions. There they are. That's our solution. Now, I'll comment that that solution tells us that the graph of this function, y equals x squared plus 3x plus 5, can't ever give you y equals 0 for any real number, because the only numbers for which you get y equals 0 are complex numbers, meaning that the graph of this function is never going to touch the x-axis or go through it. It's either going to be completely above or completely below the x-axis. That's just a little prelude. You don't have to remember that, but if it kind of registers, it's a good idea. So the discriminant tells us even more than that about the graph of the function. Okay, well, let's take this equation, y equals negative 2x squared minus 6x plus 3. We identify a as negative 2, b as negative 6, c as 3. So then we go ahead and evaluate the discriminant. Usually we're going to evaluate the discriminant first. We're going to have to do it sooner or later. We might as well do it first so we can see what kind of solutions we're going to get. Okay, our discriminant turns out to be 60. So the plus or minus the square root of our discriminant, the plus is going to give us one result, the minus is going to give us the other. Now the rest of the numbers in the quadratic formula are negative 6, which goes here with a negative in front of it, and negative 2, which goes here with 2 in front of it. because, of course, that's what the formula says. Negative b is negative of negative 6. 2a is 2 times negative 2. Okay, well, we continue that on. Negative of negative 6 is 3. And, oh boy, you know, in the preceding, I did put my negative in front of this because I wasn't that focused on that number, so I got real careless there. But the negative of the negative 6 is 6. That's going to be positive. This is going to be negative. So when we divide this by this, we get negative 6 over 4, which simplifies to negative 3 over 2. And then that's going to be plus or minus the square root of 60 over negative 4. Okay, and I've said it before, but plus or minus the square root of 60 over negative 4 gives you the same numbers as plus or minus the square root of 60 over 4, because you're going to have both a plus and a minus. It doesn't matter if you have a plus 4 or minus 4 here when you start, you're still going to get the same two numbers. And the square root of 60 simplifies to 2 square root of 15, and 2 square root of 15 over 4 simplifies to square root of 15 over 2. So our solution is negative 3/2 plus or minus the square root of 15 over 2. Both solutions are real numbers. Positive discriminant gave us 2 real solutions. But now we see all the details of the solution, and we've corrected one of them where I neglected to put my negative sign there, and then just started believing myself and never put it down. Okay, you got to be careful about that. Be more careful than I am. Okay. Now the third equation, this one, we identify A, B, and C as before, and we plug it into our discriminant. B is 6, so we get 6 squared for B squared, minus 4AC, coefficient of x squared is 1, that's A, and we have the 9. So we have 6 squared minus 4 times 1 times 9. Well, that's 36 minus 36, and that's 0. So when we plug into our quadratic formula, we're going to have negative 6 plus or minus the square root of the discriminant, but that's just the square root of 0, divided by 2 times 1. And that's just negative 6 over 2 is negative 3, and 0 over whatever is 0, so it's negative 3 plus or minus 0. Negative 3 is the only solution. It occurs twice, once for the plus, once for the minus, so we say it's a repeated solution. And of course, it's a real number, because the only way you get a complex number out of this is, or just a pure imaginary number could happen, is if you have a negative under this radical. Because otherwise, you're not going to have any complex numbers. The coefficients A, B, and C aren't complex. Okay? So that's the quadratic, the solution of each of these equations by the quadratic formula. And this is actually 1.3. I'm not keeping up very well, am I?